Good morning, dear students. Welcome back to the geography class. And today I will going to finish this chapter and I will teach you the second part of this chapter. But before we start this chapter, let us just recall what I have taught you in the previous class. So, in the previous class, if you remember, in this chapter, latitude and longitude, first of all, I explained you about the shape of the earth. And all of you know that the shape of the earth is oblate spheroid. It is also called geoid. Why it is? Because of the centrifugal force created by the gravitational force of the earth. Then I explained you about the hemisphere, the four hemisphere. So horizontally here, equator divides the earth into northern hemisphere and southern hemisphere. Then the prime meridian divides the earth into western hemisphere and eastern hemisphere. Then I explained you about the direction, that is cardinal direction. North, south, east, west are called cardinal direction. Northwest, northeast, southwest and southeast are called the intermediary direction. Then I explained you about the earth's grid. What is the earth grid? Earth grids, the network of the latitude and longitude is called earth grid. Then after that I explained you about the concept of latitude, and there I explained you how these latitudes are angular distance, why they are denoted by the degree. So I explained you that now this is in this figure. Now this is 30 degree north latitude. Why it is called 30 degree north? So when we join this line with this center part to the equator, so it forms 30 degree from the center of the earth, and that's why this latitude is called 30 degree, and as it lies in the northern hemisphere, we call it 30 degree north latitude. Well, again I explained you about the five main parallels of latitudes. What were they? Equator, Tropic of Cancer, Tropic of Capricorn and Arctic Circle. Then and another one, fifth one is the Antarctic Circle. Then I explained you about the importance of latitude. So first of all, latitude divides the earth into different heat zones. Second is the latitude together with longitude. They helps to fix the places on the globe. And the third is equator, which is the largest latitude, divides the earth into two hemispheres, that is north hemisphere and southern hemisphere. Then I explained you that how to determine the latitude. Two methods are there. First is by observing the pole star, second by observing the midday sun. Then I explained you about the different climatic zones. You know it as the heat zones. In the previous classes you may have studied about the heat zones. So here the region between the Tropic of Cancer and Tropic of Capricorn, we call it torrid zone. Then the region between the Tropic of Cancer and Arctic Circle and Tropic of Capricorn and Antarctic Circle are known as temperate zone, and the region inside the Arctic Circle and Antarctic Circle are called frigid zone. Then after that I explained you about the concept of longitude. Now what is the concept of longitude? All of you know already about the longitude. Now here if you see here this figure, this is the prime meridian and this is the 40 degree east longitude. So when these two longitudes are joined from the center of the earth, they again forms one angle, and this angle is 40 degree, and that's why this latitude, as it lies in the eastern hemisphere, it is called 40 degree east. And the same way we find out all the other longitudes. Now next is the importance of longitude. So I explained you first of all the longitudes together with the latitude, they are used to fix the places on the globe. Second is longitudes are also used to find out the great circle routes. Example, I told you. Now what is the great circle route? Here I explained you with this figure. Now these are the 2 points. Here this is London, and this place actually, because there is no place, so we just take one more point. So the plane, suppose it flies to Los Angeles to America, and from here to this point it can be a long journey. Again, if plane flies to Seoul in South Korea, and from here to this point it can be a long journey. So which is the shortest route? The straight that goes above the North Pole, and this is the shortest route. So this shortest route between the 2 points on the globe, we call it the great circle route. This great circle route is also known as the arc of great circle. Now next is the importance of great circle route. Now the great circle routes are very, very important. Why? First of all, they save fuel and time. Second, they are most advantageous for the aircrafts. And third, the sailors also use in the sea and ocean wherever it is possible. So today we are going to start about the Greenwich Mean Time. We are going to see about the local time, standard time. We are going to see the calculation of the time by the help of longitude, international date time, world time zone. Okay, let's see. Let's start with the Greenwich Mean Time. What do you mean by the Greenwich Mean Time? So let me just show you the figure here, map. Now here, this map, if you see, now here if you see here, this is a 0 degree longitude. This 0 degree longitude is also known as prime meridian. So this prime meridian passes through one place in London, near London. We call it Greenwich. So internationally, this 0 degree prime meridian, the time based on this longitude internationally is accepted as the international time. And so because it goes through the place Greenwich, we call it GMT or Greenwich Mean Time. Now in 1884, this time based on the prime meridian was accepted as international time. So all the time of the different countries, they are fixed according to this GMT. Now let us move to the next one, that is a local time. Now let's see what is a local time. So local time. Now usually in the ancient time and even up to the medieval period, the people, they fix the time according to the midday sun, because that time there was only known time, known method to find out the time actually is the sun. At some places you can find the sun dial is there. One example, like Jantar Mantar, all of you know, you have heard about, that is in Delhi. Now what is a Jantar Mantar? It is a sun dial. So time is actually calculated, right? Now how? By the help of the shadow created by the sun rays. The sun actually at the different time of the day, it creates a different angle, and that actually shows the time. Well, so the different places actually, they follows the sun time. During the midday time, the sand clock was fixed, and that time was followed by the whole city. So every cities, they used to follow the different time, and so this time was known as local time. Now usually in the present day, if we follow this time, the local time, it can create a great confusion. And so now we don't follow the local time. And instead of the local time, we follow the standard time. Now let's see here what is the standard time. So here is the map of India, And first of all, we're going to see what is the standard time. So standard time actually is a uniform time. We can also call the standard time as the uniform time of any country. Like in India, India is a big country. So here actually a central meridian, that is 82.5 degree, which actually almost goes from the center of the country. It is taken as a central meridian, and the time which is based on 82.5 degree east in India, this time is followed by the whole country, and so this time is called Indian Standard Time. So what is the standard time? The time based on the central meridian of any country or region as a uniform time for the whole country or region is called standard time. Same way, if you'll find in Pakistan, the central meridian there, it is time that is based on the central meridian passes through Pakistan. We call it Pakistan Standard Time, in short PST. Now in Sri Lanka, we call it Sri Lanka Standard Time, and Nepal, we call it Nepal Standard Time. But now if you find the India and Nepal and Sri Lanka, all these countries, they almost fall on this latitude 82.5 degree east longitude. So the time based on it 82.5 degree east longitude, this time is also followed by Sri Lanka and even Nepal. So these are the three countries which follows the same time based on 82.5 degree east. You can say this is why, one more thing, if you'll find, if you go to Nepal or Sri Lanka, you don't have to change the time because the time is the same. So this is the standard time. But let's see some more facts about the standard time. Now you must be knowing about the countries like USA, Canada, Australia and Russia. Now these countries are very big countries, and their east to west longitudinal extent is very, very big. So they can't follow any one standard time. Why? Because if you'll find Russia is very big, and if they follow any time based on any central meridian, there will be a great confusion. Why? Because if suppose central time, the time actually is 12 o'clock, right, noon time, but to the most eastern part of Russia, there will be a morning. They will see the sun rising. While in the west, what will happen? They will experience evening time. So that will create a big problem, a great confusion. This is why these big countries like USA, Canada, Australia and Russia, they follows many standard time. Because why? They are very, very big countries, and their east to west longitudinal extent is very, very large. And that's why if you go to USA, you will find USA follows 5 standard time. The 5 different standard times is been followed by USA. The same with the Canada. Canada also follows the 5 standard time. Russia, which is very big, it follows 11 standard times. Well, these are some facts about the standard time. Now let's see about the world time zone. Now what do you mean by the world time zone? So you can see here, each time zone in the world differs from the next by 15 degree in longitude. 15 degree means 1 hour in time. How you will find this 1 hour or 15 degree. Now if you see, the whole earth is round in shape, so we can take it as a 360 degree, and if we divide 360 degree by 15 degree, we get 24 zones. So the whole world can be divided into 24 time zones of 1 hour each. Why? Because if you'll find, now suppose you just do it opposite. If you divide 360 degree by 24, 24 is what? 24 hours. Now look here, I have done here. 360 degree divided by 24 hours, what you will get? 1 hour equal to 15 minutes. Same way, in 1 hour there is a 60 minutes, and you divide 60 minutes by 15 degree, again you will get how much? 1 degree will equal to 4 minutes. Well, this is the one calculation. We will see afterward. It will help you in calculating the time. So what is the world time zone? The whole world actually is divided into different time zones of the equal duration, because all of you know the earth takes 24 hours to complete one rotation. In this way, each hour time zone is equal to 15 degree. Now let's see here. Now let's see about the time, local time, that how you are going to find the local time. So look here. First of all, we are going to see to find the local time when we know the longitude. So let's see here some example here. The first example here, if the GMT at 0 degree longitude is 12 noon, this question is find the local time at station A and B. Now station A is located at 60 degree east longitude, while station B is located at 30 degree west longitude. So first of all, you need to draw one diagram here like this. Now this is in center, this is 0 degree GMT. Now look here. Now the first one, the station A is located at 60 degree east longitude. 60 degree east means this longitude will be towards the east. So here this line I have drawn, and that shows 60 degree east. Station B is located at 30 degree west. So west means towards the west side. Now this is 30 degree west. So now let's see here. So we have to find out the time. One time that is located on 60 degree east, and second one we have to find the time that is located on 30 degree west. So the first one, station A, let's see here. But before that, let me explain one more thing. Again, let's revise it. So as all of you know, 24 hours means the whole earth can be taken as 360 degree, and the whole earth completes one rotation in 24 hours. So when we divide 360 degree by 24 hours, we get 1 hour is equal to 15 degree. 1 hour means 60 minutes. Now when this 60 minutes is divided by this 15 degree, what will happen? We get 1 degree is equal to 4 minutes. So this is a normal thing. All of you now I think have understood that 1 degree, according to this calculation, we know now that 1 degree is equal to 4 minutes. So let's see here. So the station A, the difference between 0 degree and the station A is 60 degree towards the east. Now 60 degree, when we multiply by 4, we get 240 minutes, that is 4 hours. Now because this place is located towards east, so here this 4 hour will be added to 12 noon. How much time we will get? We will get 4 p.m. that is evening. Now the second, let's see the second example. Station B. Difference between the station B and 0 degree, that is the GMT prime meridian, is 30 degree west. Now B actually is located actually on 30 degree west. So difference is 30 degree. Now when we multiply this 30 degree by 4, we get 120 minutes, that is 2 hours. So but the thing is, here this place B is situated towards west. Now here we need to reduce the time. We have to subtract 2 hours from this 12 noon. So here when 2 is subtracted from 12, how much we get? 10. Now this will be AM, means morning time. So the time here at 30 degree west will be 10 AM. So this is the method by which you have to find the time when you know the longitude. Now next is another method is to find the longitude when time is given. When you know the time, how you will find the longitude? So we are going to see another example. Here the question is, what is the longitude of station A, whose local time is 7 PM, while GMT is 12 noon? Now here is time. First of all, at GMT the time is 12 noon, and this time here at the station A is 7 PM. 7 PM means this lies towards east. Why? Because it is a night time, 7 PM. Now here is noon, means it is a added time. So I have drawn this line here, this line towards east. Well, so the longitude will be east. We come to know, right, like this, that the longitude will be east longitude. Now let's see how you're going to find. So first of all, we have to find the time difference between the GMT and station A. Now this time difference is 7 hours. Now on GMT the time is 12 noon, and station A the time is 7 PM. So the difference is 7 hours. This 7 hours multiplied by 60 minutes, we get 420 minutes. And in this way, we know 1 degree is equal to 4 minutes. All of you know this. So when we divide 420 minutes by 4 minutes, we get 105 degree. And all of you know, already I told you, this is east longitude. So this will be 105 degree east longitude. So this is how we calculate the longitude when we know the time. Now next is the international date line. What do you mean by the international date line? Now usually the international date line is an imaginary line along the 180 degree meridian, extending from pole to pole concerning with the dates of the calendar, and it is also adopted internationally. Now let me explain you about the international date line. Now, but before that, let me show you some figure. Now look here, the first figure here. This figure, if you see, this central line is 0 degree meridian. And now when you see the globe from this side, means from the side where you can see the prime meridian, 0 degree meridian longitude. Now east will be towards the right hand side and west will be towards the left hand side. Now let's see another figure here, and in this figure if you see, now here if you see, this is also another figure, and this is, but this line here in the center is not 0 degree. This is 180 degree longitude. We call it 180 degree meridian also, right? Now when you look the globe from the side where you can see 180 degree meridian, what will happen? Now west will be, you will see the west on the right hand side and east will be on the left hand side. So you can find here 160 degree west, 140 degree west, here 120 degree west. Now towards the left hand side 160 degree east, 140 degree east. So this is just opposite of that figure. So when you see the globe from two sides, one side, that is from where you can see the prime meridian, you will see the eastern longitudes, they lies to the right hand side, and the western longitudes, they lies to the left hand side, and the eastern longitudes towards the right hand side. So once again, eastern longitudes, they lies in the right hand side, towards the right hand side, and the western longitudes lies towards the left hand side. But it just get reversed when you see the globe from the another side, where you can see the 180 degree meridian. Now this time what happened? Western longitude will be right hand side and the eastern longitude will be on the left hand side. Now let's see here one more map. Let me show you. Now this is the one more figure. Now this map, actually you can see here, this is the 0 degree longitude. Now all of you know one thing, now have already understood that when you move towards the west, you reduce the time, right? The time is subtracted and you lose the time. So slowly and slowly what will happen? Towards, now suppose here is a 0 degree, 12 noon, usually the time actually that is fixed, 0 degree is 12 noon. So when you move towards the west side, so you will see that time will be reduced. Like example, now here at 60 degree, the time will be 7 p.m. Then at Los Angeles, the time will be 4 a.m. right? And continuously it will become what? Now when you move towards the 180 degree, here you will see one thing. You will see the time will be 12 midnight. Let me again revise it. So when you move from the 0 degree prime meridian towards west, you will lose time and a stage will come at 180 degree. The time will become midnight. Again, when you move towards the eastern side, now from here 12 noon, you will gain the time, but when you will reach 180 degree, again you will see time will become 12 midnight. So usually when the time on 0 degree is taken as 12 noon, so time at 180 degree we used to take it as 12 midnight, 12 o'clock midnight. Now all of you already know that the date gets changed at midnight. So let's see here. So now let's come back here. Let me just explain you what happened. In 1522, all of you must be knowing about the Magellan cruise. They just completed the whole circumnavigation. So the Magellan, actually he died on the way, in journey. Actually he didn't reach to the destination, to the home. He died on the way. But Magellan's crew, all the members, not all but some of them who survived, so they reached home after circumnavigation of the world. And when they reached to their place in Europe, so as they were calculating the time, and they were thinking that the time will be usually 5th September according to the calculation, because they used to keep the record of the time of each day So according to them, they reached on 5th September, but when they reach there, they find out that the date is 6th September. Now, every day they have just calculated the date. They have mentioned the date. Every day they have added the date. So they have kept just watching the date. And then also they saw that there is a 1 day difference. And after that actually they find out actually what happened here, that usually at 180 degree here, this another map figure, let me show you. So usually what happened at 180 degree, there is a there is a change of date. Now if suppose there is a Sunday in the western hemisphere, I told you, right, here will be the western will be in the right hand side and eastern will be left hand side, because we are watching this globe from this side, from the another side, right, and we are watching 180 degree. So here what happens, when anybody cross this line from west to east, so usually what happen, 1 day is added. Why? Because all of you know this is a midnight. This time actually on 180 degree is midnight. So usually when we cross this line, so we have to alter our watch, the whole 24 hours, and 1 day we add. So if here is Sunday, it will become Monday. But if anybody crossing this line from east to west, what they have to do, they have to subtract a day. Now if it is Monday here in the eastern hemisphere, now in the western hemisphere it will become Sunday. So this is why this 180 degree actually, this line 180 degree longitude is internationally adopted as the international date line. So on this line actually, if any plane or any ship they cross the line, so they have to adjust the day, they have to adjust the whole 1 day, right? So you can find here, let me just show you here. Okay, one more thing. Now if you'll find here, this is the international date line, but this international date line is taken, 180 degrees taken as international date line, but this line is not straight. Here you can see it is zigzag. Why it is zigzag? Why it is not straight? So here if you see here this map, 180 degree is going through Russia. Now if we follow this straight line, there will be a confusion will be created within the Russia, confusion of date. This is why here this line is deviated towards this side. And again here you can find that these are the so many islands are here, these all belongs to USA. So here again this line deviated towards the west. Now again here in the southern hemisphere also you will find there is a great deviation there. Why? Because so many islands are here. These all islands, they belongs to one group. And just to avoid the confusion, this line also is deviated here also, right? So this is the international date line. So what is the international date line? This international date line actually, that is 180 degree longitude, is taken as an international date line, and usually the date actually is fixed, or it is checked when anybody cross this line. Another thing, why this line is not straight, why it is zigzag? So it is because to remove the confusion, that convenience caused by this straight line, this line actually is zigzag, right? And it is also internationally accepted. So this is over now. and very soon you will get some notes. I will provide you the notes and homework also, and all the notes will be published there on the school's website, so you can download from there. Homework also will be given there, so you have to just do the homework also, and you can go through the notes. So all the best. So this chapter is over now, because this chapter is already over, and now that's why. Now next period, let me give you a glimpse that what we are going to start next period. So next session we are going to start about the third chapter, that is rotation and revolution. And those actually who have arranged the book, so it is good for you. So you just read this chapter, rotation and revolution, and try to find out the answer also from the exercises, all the questions which is given in the exercise. So find out the answer. Very soon the notes which I will provide you, so it will contain all the answers, right? And you have to find out the answers from there. Very easily you can get. Now, so let's come back here, rotation and revolution. Now in this rotation and revolution, what you will study? So you will be studying about some very common things, but some more things. Like example, you will study about the movement of the earth, that is rotation and revolution, already all of you know. Then you will study about the circle of illumination. Well, all of you know, must be knowing about it. You will come to know about the sidereal day. Then effects of speed of rotation, how this effect of speed of rotation is different from the effect of rotation. So this you will see. Then you will study about the Coriolis effect. This is also known as it is also known as Farrell's law. You will study about the centrifugal force. Then you will study about the revolution. Then the different types of ear, how these ears are known by the different names. You will study about the perihelion and aphelion, speed of revolution. You will study about the inclination of the axis and its significance, effects of the inclination of the axis. You will study about the revolution of the earth and seasonal changes. Then again you will study about the winter solstice, summer solstice, equinoxes. So this chapter is also very small, and so we will start this thing afresh. So today up to here only. All the best to all of you. So try to just find out the answer of the previous chapters. Very soon I will provide you the notes. Another thing, all of you read the third chapter. When you will read the third chapter, it will become very easier for you. So good day all of you. Bye bye.